Among the following, the total number of species not having 8 electrons around the central atom in its outermost shell is. They're all from the chapter chemical bonding. A basic question they are preferring, dear all. NH3, nitrogen, hydrogen, and there is a lone pair. Nitrogen completed its octet or not? They're asking on central atom which all species central atom carry 8 electron. So nitrogen here 2 electron, 4, 6 and 8. Yes, it's having 8 electron. AlCl3, see dear all, AlCl3, aluminium only 3 bond, 3 bond mean only 6 electron, so not completed its octet. What about beryllium chloride, BeCl2, beryllium connected to only 2 bond mean 4 electron, that not completed their octet, so this is also octet is not completed. What about CCl4, tetrahedral shape where chlorine connected to carbon, all 4 bonds are what? Same one, 8 electrons are there, it's completed their octet. What about PCl5? PCl5 when you consider, it's having a trigonal pyramidal shape where phosphorus is expansion of octet because there is 5 bonds with the phosphorus. 5 bonds means what? 10 electron. It's more than 8, right? So it's not also not an answer. So these 3 species are not completed their 8 electron in their what? The central atom not bring 8 electron exactly. So which one? 3 compounds are there without completion of that 8 electron with the central metal atom. Intermolecular forces are forces of attraction and repulsion between interacting particles that will include. From the chapter the states of matter, again second question from states of matter, from the beginning part there are intermolecular forces of attraction, they are all which all van der Waals force, hydrogen bond, etc. Right, which all are the van der Waals forces? Dipole attraction, dipole induced dipole attraction, London or dispersion forces are there, and even hydrogen bond also is an intermolecular attraction. Covalent bond is not an intermolecular force, it's an interatomic force, right? Atomic force. So ABCE, that is option number 2 is correct for which one? Question number 74. Let's go to question number 75, dear all. Assertion. A metallic sodium dissolved in, from the chapter S block element from grade 11. Metallic sodium dissolves in liquid ammonia giving a deep blue solution which is paramagnetic. Is it correct, dear all? You may study a metal when react with X plus Y amount of ammonia. You may study a general equation in S block. When metal combined with the X plus Y amount of ammonia, it will combine M combined with the X amount of ammonia with the charge plus, and metal lose that electron combined with the ammonia and Y time with the charge minus. And you may study that this electron we named as what? A ammoniated electron. Ammoniated electron, he is the one responsible for the deep blue color of the solution, and there is only one electron. It's what? Paramagnetic in nature. Assertion is correct. Reason: the deep blue solution is due to the formation of amide. There is no formation of amide. This ammoniated electron is the responsible one for making color. So assertion is correct. Reason is wrong, dear all. Option number 2 we can proceed. Next one, question number 76. That is the element expected to form. It's just a question from the classification of element, grade 11, third chapter. The element expected to form largest ion to achieve the nearest noble gas configuration. How fluorine can attain configuration, dear all? Noble gas F minus. When it get 1 electron, 8 completed. Nitrogen, if it get 3 more electron, it completed. So N3 minus. Sodium, if it lose 1 electron, it completed. Oxygen, if it gain 2 electron, it octet completed. Which one having greater size? Anyway, sodium I can cut it because sodium is a cation. Anions are bigger. Among the anion, greater the charge, greater the size, right? So option number 2 having greater charge, it bring a noble gas configuration. Next one. Some tranquilizers are listed below. Which one from the following belongs to barbiturates? You study in the chemistry in everyday life, the medicines and their purpose and all. Barbiturates, the one which is used for what? Reducing stress and all to get good sleep. That is what? Veronal. That is option number 3. Next one. Given below assertion. In equation delta G from the again chapter electrochemistry, in equation delta G Gibbs energy, Gibbs energy and E cell relation minus NF E cell. All right. A delta G depend on N. Yes, delta G depends on N as per the equation. The number of electron transferred. Yes. E cell is an intensive property and delta G extensive property connected to thermodynamics. You know, E cell, what is E cell? The EMF of the cell, that is intensive property. Yes, it not depends on the number of particle, but delta G is an extensive property. Yes, it depends on the number of particle. So dear all, that's also a correct statement and a correct reason, right? As per the equation, yes, it depends on the number of particles. So dear all, both are correct and it's a correct explanation also. Question option number 1. Question number 79. From the chapter polymer, right? From the chapter polymer, it's compulsory to know each polymer and the corresponding monomers, etc. Which among the following molecule polymerizes to produce neoprene? You know, neoprene is also called what? Polychloroprene, where the monomer is chloroprene. What is chloroprene, dear all? CH2 double bond, CH single bond, sorry, CH double bond, CCl, then CH double bond, CH2. What is this compound, dear all? 2-chloro-1,3-butadiene. It is a polymer. 2-chloro-1,3-butadiene. It is the monomer of which one? Neoprene. Neoprene is also called polychloroprene, where the monomer is what? Chloroprene. So what is the answer? First one. If you know the name, neoprene is also called a polychloroprene. Chlorine, which included only one species is given. Option number 1. Polymer chapter. Question number 18 from the chapter again. Which one? Organic chemistry, the aldehydes, ketones and carboxylic acid. Very simple question, dear all. They given cyclohexane and with a ketone. So cyclohexanone is ready. First they are treating with what? Hydrogen cyanide. You know, it's a nucleophilic addition reaction. When hydrogen cyanide that you added, Cn minus nucleophile attack here and O become O minus. So we will get a product here, cyclohexane with what? O minus, and here cyanide attack. To the O minus, this H plus will attack, dear all. So you will get cyanide and OH together, what we call cyanohydrin. Alright. When it is treated with what? Concentrated H2SO4 and heat. It's an acid, right? You are heating with an acid. You know what happened to alcohol if you heat with an acid? It undergo dehydration. What is dehydration? OH take from alpha, one hydrogen take from beta and make a double bond between alpha beta. So you will get an alkene like this one with what? Cyanide. But dear all, cyanide also react with what? Acid. Cyanide also react with acid. You know, cyanide, what happened when you treat it with acid? It become carboxylic acid. So cyanide, OH undergo dehydration. Cyanide become what? Carboxylic acid, dear all. So what is the answer suitable for this one, dear all? That is option number 3. Yes, from the chapter aldehydes, ketones and carboxylic acid, nucleophilic addition. Question number 81. Weight of 2 moles of an organic compound which is obtained by heating sodium ethanovate. Sodium ethanovate. What is sodium ethanovate, dear all? CH3COO-Na. Sodium ethanovate. Sodium ethanate with the sodium hydroxide. With the sodium hydroxide in presence of calcium oxide. Dear all, which chapter? Even 11th grade and 11th grade hydrocarbon chapter, grade 12 aldehyde chapter, you studied about this reaction. What is the name of the reaction, dear all? Decarboxylation, right? Calcium oxide and sodium hydroxide. What it's called? Soda lime, right? Soda lime, it's used as what? As a decarboxylating agent. What happened during decarboxylation? Remove the carbon dioxide part, put one hydrogen on this part, you will get CH4 as a product. You will get an alkane, right? You will get an alkane. What is the formula? CH4 methane, its mass is what? 16, right? Carbon 12, 4 hydrogen 4, 12 plus 4, 16. So 16 is not the answer. The weight is 16 gram, but question, if 2 moles of the organic compound, 1 mole give you 16, so 2 moles will give you its double, that is what? 32. So answer is what? Option A is the correct answer. Next one, 82. Which of the following will not give you a primary amine? Dear all, carefully listen, simple one. Cyanide. You know, cyanide or nitrile on reduction, what you will get, dear all? Its corresponding amine will form. Yes, it's a primary amine. This is an isocyanide, right? Isocyanide, dear all, it's on reduction. What you will get, dear all? You will get a secondary. You will get a secondary amine. Yes, so answer is number 2. Where you won't get primary, that's a question. What about amide on reduction, dear all? Amide, that's also on reduction. What we are getting? A primary amine. And this amide on which one? the name in reaction you studied, Hoffman bromamide degradation reaction, you will get a amine which one carbon less. Yes, here also. But option A 1, 3, 4 are giving you primary amine. Option number 2 giving you secondary amine. Remember, cyanide on reduction primary amine, isocyanide on reduction secondary amine can form. Next one. The right option for the mass of carbon dioxide produced by heating 20 gram 20% pure limestone is. You know what is limestone? Calcium carbonate. Calcium carbonate on heating, yes, you will get calcium oxide and carbon dioxide reaction is given. Question. The right option of the mass of carbon dioxide produced by heating 20 gram of 20% pure limestone. Immediately don't go to the question dear all. As per the reaction, what is the weight of calcium carbonate? Calcium 40, carbon 12, oxygen 3 into 16. The mass of calcium carbonate is total 100 gram. As per the question, 100 gram calcium carbonate when decomposed, I think it's balanced one. How much carbon dioxide you will get? Carbon dioxide, carbon 12, O2 32, or total 44 gram of carbon dioxide. As per the question, 100 gram calcium carbonate decomposed giving you 44 gram carbon dioxide. So what about as per the question, you have 20 gram 20% limestone. What do you mean by 20 gram 20% dear all? 20 gram 20%, which means what? 20 into 20 by 100, right? 20 gram means 20% means what? 20 into 20 by 100. So it's equal to what? That's 1 by 5, right? Like that we can able to calculate it. So 20 by 5, that's equal to what? 4. Now, so 100 gram calcium carbonate giving you 44 gram carbon dioxide. So here how much gram? You have 4 grams. So what about 4 gram calcium carbonate dear all? 4 gram calcium carbonate need 44 divided by 100 into 4. Yes, so dividing by 2, so it's 50, it's 2, again 25, then 1. 44 divided by 25 nearly is equal to 1.76. So dear all, it's a stoichiometric question from the chapter Some Basic Concepts of Chemistry from grade 11 first chapter. So calcium carbonate on decomposition, you will get calcium oxide and carbon dioxide. So calcium carbonate as per the reaction, 100 gram calcium carbonate is there giving you 44 gram carbon dioxide. As per the question, you are taking 20 gram 20%. What do you mean by 20 gram 20%? 20 into 20 by 100. So you will getting 4 gram calcium carbonate need this 1.76 gram. It produces 1.76 gram carbon dioxide. Option number 1. Now, identify the product in the following reaction. It's a related to many of the organic chapter, starting with the amine chapter. Dear all, it's benzene diazonium chloride. You know, benzene diazonium chloride. First, they are treating with the what? Cu2Br2, Cu2Br2 or HBr. What's the reaction dear all? Sand-Meyer's reaction. What happened to this one? You will get benzene with what? Br, right? Bromine, you will get it. Bromobenzene. Secondly, they are treating with what? Mg in presence of what? Dry ether. What is the reaction dear all? Formation of Grignard reagent. We can put the Mg in the this area, you will get MgBr. You know, Grignard reagent Mg plus and the alkyl part or the phenyl part is minus. Finally, they are going to treat it with the what? H2O. Dear all, H2O contain the ions H plus and OH minus. They will go to the opposite pole. So the Mg plus, that OH minus will attack. That's a byproduct. To the O minus, H plus will attack. What is benzene with this H dear all? That's nothing but that's a phenyl group with this H is what? That's benzene. That's option A is the correct answer. So first one, benzene diazonium chloride on Sandmeyer, you will get bromobenzene. Bromobenzene treated with the Mg dry ether will get Grignard reagent. Grignard reagent treated with water, it form benzene here, right? Next one, the number of sigma bond, pi bond and lone pair of electron in pyridine. What is pyridine dear all? Pyridine, you know, pyridine compound is like this, right? This is the structure of what? Pyridine. You know, pyridine, that's carry, nitrogen carry one lone pair. So lone pair number is 1. What about the sigma? You know, if you want to calculate the sigma bond and pi bond, it's compulsory to take the each and every bond, okay? So this is what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Any hydrogen bond left in this one? 1, 2, 3, 4, 5 from the hydrogen. So 5 sigma bond, then 1, 2, 3, 4, 5, 6. So 6 plus 5, 11 sigma bonds are there. How many pi bond here all? 1, 2, 3. 3 pi bond and 1 lone pair is present, right? So 11, 3, 1. 11, 3, 1. Option number 2 is the correct answer. Next one. Which among the following from the chapter thermodynamics from grade 11? Very simple question. They are asking only just the relation. What is the relation between enthalpy and internal energy, dear all? You know, delta H is equal to delta U plus P delta V. Instead of P delta V, we can write delta H equal to delta U plus delta NG RT. Many times we did the numericals and all. You can able to see the answer is which one? Option number 1. Delta H and delta U relation they are asking. Now, consider the following reaction. A repeated question in the NEET examination, even from the direct question from the NCERT textbook exercise pattern. You know, this is an ether. When we treat it with HI, ether CO bond can break. Dear all, it's an aromatic ether. In the case of aromatic ether, just remember one point. You have H plus and I minus. When you breaking the CO bond, either you can break the CO bond or the CO bond. If it is an aromatic ether, just keep in mind, after the break, we should get phenoxide ion. After the break, we should get what? Phenoxide ion. So where we want to break, dear all? You want to break here. Yes, we are getting phenoxide and a benzyl here. So iodine come to this part and H go to this part. So you will get the compound as benzene with CH2I and phenol. What is the product, dear all? Ether bond, cleavage of CO bond in ether. So the answer is which one? CH2I, right. Option number 2. From the chapter which one? Alcohol, phenols and ether from grade 12. 88. Which of the following statements are incorrect? Incorrect. All the transition from D block element chapter, dear all question. All the transition metals except scandium form metal oxide which are ionic. You know, scandium speciality, scandium major oxidation state is the only one oxidation state is +3. If it is MO, MO means metal +2, oxygen -2. Is scandium is in +2 state? No, scandium is in +3 state. So the this one is incorrect statement, a correct answer. So question is which is incorrect, right? So all the transition metal except scandium. Sorry for that. Statement is correct or not? Yes, because scandium oxidation state is what? +3. It cannot form what? +2 state. Yes, the correct statement is given. The highest oxidation number corresponding to the group number in transition metal oxide is attained in scandium. Yeah, here scandium 3 + 2, Mn + 7. Yeah, scandium to Mn oxidation state, the highest oxidation state number that's corresponding to the group number. Yes, correct one. Basic character increases from V2O3 to V2O4 to V2O5. You know, V2O5 is mostly amphoteric one. V2O3 to V2O5, dear all, basic character decreases, not increases. Why? A small thing you can able to say. What is the oxidation state of vanadium in V2O5? 2 vanadium and 3 oxygen, so -6, overall 0. 2x is equal to 6, x is equal to what? +3. Here vanadium +3 state. What about V2O4? 2 vanadium, so 2x plus 4 oxygen -8 equal to 0, x equal to what? +4. You know, normally higher the oxidation state, higher acidity. So higher the oxidation state, lower basicity. A small idea. So we can able to say V2O3 to V2O5, what happened? The oxidation state decreases, increases, so basicity decreases. V2O4 dissolves in acid to give VO4 3-. They're all V2O5 dissolves in acid giving you VO3. This is a wrong statement. This is also wrong statement. Now, CRO is basic, but Cr2O3 is amphoteric. Yes, the basic and amphoteric oxide list you already studied. So, there are which all are incorrect statement? That's a question. A is correct, B is correct, C, D are incorrect, right? C and D are incorrect. So which is that answer? Option 2 is the correct answer. Next one. Which among the following be most readily dehydrated under acidic condition? See, all our alcohols here. You know, alcohols on dehydration, you will get alkene. So which will undergo reaction fast or not, you want to understand that after the reaction, whether it getting stability or not. Yes, then only they undergo reaction, right? So dear all, if you consider these two OH species, if you remove this OH, you will get carbocation. If you remove this one OH, you will get carbocation. If you remove this OH, you will get the carbocation this side. So these are the carbocation formed in these cases, right? These are the carbocation formed in these cases. Which carbocation is the most stable one, where the reaction happen faster, where the OH removal is faster, right? So which one is more stable carbocation, dear all? Which one is more stable carbocation? Dear all, let's go with option 3. Why? Because if this carbocation form near to that, it's far away, not near. NO2 group is there. What is NO2 group? It's an electron withdrawing group. You know, the stability of a carbocation increased by presence of electron donating group, not withdrawing group. Withdrawing group, that will decrease the stability of what? Carbocation. Here the withdrawing group is far away from the carbocation. But what about these cases and all? Here you can able to see nitro group is there. These all are very close to the carbocation, right? If the withdrawing group close to the carbocation, it decreases the stability. Here is far away, it increases the stability. So remember, dear all, electron donating groups are the one. Plus I groups increase the stability of carbocation. Minus I group with decrease the stability of carbocation. So 3. A reaction that does not takes place in a blast furnace. You know, blast furnace, the extraction of iron from the chapter metallurgy from grade 11, right? The blast furnace, which of the reaction not going to occur? You know, there are different region, different zone for the blast furnace, right? Combustion zone, fusion zone, slag formation zone, etc. Which reaction does not takes place in this one? Dear all, the answer is, we can able to say fourth one, that's reaction is not happening in blast furnace. You know, the reaction is what? Fe2O3CO, it will give you what? Fe3O4 and carbon dioxide, not Fe with oxygen. You know, yes, this Fe formation is happening there, carbon monoxide formation is happening there, the slag formation is happening there. Yes, all are correct one. Fourth one is the incorrect statement. Now, identify the major product obtained in the following reaction. Again from the chapter aldehydes, ketones and carboxylic acid, dear all. This given reaction is very simple. There is a benzene ring mentioned, and what is this, dear all? This is a ketone part, and what is this, dear all? It's an aldehyde part. Try to understand what is the reagent given. That is tolerance reagent, right? Ammoniacal silver nitrate. Tolerance reagent that will always react on an aldehyde, not on ketone. And what happened to the aldehyde? Aldehyde become the salt of the carboxylic acid. So what is the answer, dear all? Ketone remain the same, and the aldehyde part become, it oxidize. You know, tolerance reagent oxidizing one, it oxidizes the aldehyde to acid. Answer is number 2. Next, what fraction of one edge-centered? So again from the chapter solid state, what fraction of one edge-centered octahedral void? Dear all, we consider a cubic structure. You know, if the particle present at the corner, you know, a corner particle is shared by 8 adjacent spheres. So the contribution from the corner is what? 1 by 8. If the sphere is present at the center of the face, a face-centered atom is shared by what? 2 spheres, 2 unit cell. So if from each face center, you will get half portion inside. Half is the contribution. They're asking you edge-centered, dear all. Edge-centered, if there is any sphere, it is connected by what? 4 unit cell, right? On top, this right, and then again the same like one more in the other side. So one corner atom or sphere is shared by 8 adjacent spheres. One face center is shared by 2 spheres, so half portion get inside. A edge-centered sphere connected to 4 adjacent unit cell, so 1 by 4th only the contribution from what? Edge-centered. So 1 by 4, 2 is the correct answer. Next one, the equilibrium concentration, chapter equilibrium, grade 11. The equilibrium concentration of the species in the reaction A plus B giving you C plus D are. Their equilibrium concentration of A, B, C, D are given 2, 3, 10 and 6 mole per liter. So let me calculate the Kc value, dear all. What is Kc? Concentration of product divided by concentration of reactant. What are the product? C and D. So 10 into 6 divided by, what is the reactant? 2 into 3, A and B. So 10 into 6, 60 by divided by 6 is equal to, that is 10, right? Now, what is the question? Temperature is given 300 Kelvin. Universal gas constant is given R. What is the question? The standard Gibbs energy we need to calculate. What is the relation between Gibbs energy and equilibrium constant? Minus 2.303 RT into log Kc is the equation, dear all. So we can able to say delta G equal to minus 2.303. What is the R value? 2 into temperature, 300 into log Kc. Kc value is what? 10. You know log 10 is equal to what? 1. So the calculation is simple. Minus 2.303 into 600. That's equal to what, dear all? 62. Just to check it, all of you. It's definitely a 4-digit number. That's option number 2. 1381 minus. Right. Next one. Consider the following compound species, the number of compound species which obey Huckel's rule. Chapter which one, dear all? You studied in the organic chapter, the hydrocarbon from grade 11, whether the complex, the given compound is aromatic or not. We can able to say by the help of which rule? Huckel's rule. What are the Huckel's rule? Says that compound should be planar, there should be 4n plus 2 pi electron, and they should, what the resonance conjugation should be possible. Dear all, let me check the pi electron first, okay? You know what is 4n plus 2 pi electron? 4n plus 2 pi electron system, right? They're all here. How many pi electron? 1, 2, 3, 4, 5. 5 bond means 10 pi electron. 10 pi electron. Here, what is these two bonds already there? This lone pair also involved in resonance. So 2, 4, 6 pi electrons are there. What about here? There is only 2 pi bond, that is 4 pi electron. Here this one and this also involved in resonance, total 2 plus 2, 4 pi electrons. What about here? Only 2 pi electrons. What about this one? 4 pi bond, that means 8 pi electron. Here 1, 2, 3, 4, 5, 6, 7, right? 7 pi electron, 7 pi bonds are there. That means around 14 pi electrons are there. You know here, what are the possible values of n, dear all? N can be 0, 1, 2, 3, 4, etc. If n equal to 0, how many pi electrons will be there? There will be 2 pi electrons. If n equal to 1, there will be what? N equal to 1 mean 6 pi electron. If n equal to 2, there will be what? 10 pi electron. If n equal to 3, 14 pi electrons, like that. So, dear all, except this pi electron, let me cut the system. 8 pi electron not in our system, and 14 to 4 is not in our system, right? 4 is not in our system. 4 is not in our system. 10, 6 remaining all are possible. Dear all are sp2 carbon atoms, and resonance is possible in all cases. 1, compound 1, 2, 5, 6, and this one. So around 1, 2, 3, 4. Right, these 4 compounds are what? Aromatic in nature. 4 compounds are aromatic. Yes, option 4. Next one. Which complex compound is most stable? From the chapter coordination complex, again, dear all, coordination complex, the stability question is a repeated one, you know very well. Complex stability increases if there is a chelating ligand present, either bidentate or polydentate. You know, this contain all are monodentate ligand. Amine and nitrate, they are monodentate ligand. Chlorine is monodentate, but En is what? Bidentate ligand. It can form chelation ring structure. But this is monodentate ligand. These all are monodentate ligand. So option number 2 is the correct answer because it makes chelation. What is the structure, dear all? Here we have cobalt is the central metal atom, and we have the En as a ligand, right? We can place the En like this one. You know, En can able to form a ring structure with the metal atom. Right, En can provide to bidentate ligand. It can form a ring structure with the metal atom. It make more stability. The effect is what? Chelation. 96. On balance in the given, the direct question from the NCERT from the chapter D and F block element, the potassium dichromate and KMnO4 part you may studied, they are used as a best oxidizing agent here, all right. So here in acidic medium with the SO3 minus, how dichromate that react, that oxidizes, that's a question here all. It's direct from NCERT. All the reaction we have to suppose to know. That's what the by balancing you will get 1, 3, around 8, 1, 3, 8. That will be the balancing, you will get it. That's option number 4, the chapter D and F block element balancing. Statement 1, the nutrient deficiency water bodies leads to eutrophication. You may study it in the environmental chemistry part. The nutrient deficiency water bodies leads to eutrophication. You know, eutrophication is the one the deficiency, right? The deficiency oxygen in the water. The nutrient deficient water, no. Nutrient water, that statement is not right. Nutrient rich one, rich one water bodies leads to eutrophication. You know, because of the some plants, they will absorb the water and all. So the oxygen deficiency will be there in water. That's what we call the what? Eutrophication. So that is a wrong statement, right? Then eutrophication leads to decrease in the level of oxygen in the water bodies. Eutrophication leads to the decrease in the level of oxygen in the water bodies. Correct or not? Yes. Eutrophication leads to decrease. You know, the algae, this kind of plants particle, when it is present in water, they will take the oxygen from the water. So the water which is deficient in what? Oxygen amount. So what happened? Eutrophication leads to decrease in the level of oxygen in water. That is a correct one. What is option statement 1 is wrong here all? Nutrient deficiency water bodies leads to eutrophication. No, that's the wrong one. So answer is option number 3. Next, identify the final product D in the above sequence of reaction. What is this compound here all? Aldehyde, right? CH3CHO. Ethanol is given. Ethanol when treated with or undergo reduction, what you will get? A aldehyde on reduction, alcohol, right? Primary alcohol. You will get CH3 CH2OH, primary alcohol. Alcohol when treated with acid in presence of acid H2SO for heating, what happened? Dehydration happen. So OH take from alpha, hydrogen take from beta, make a double bond between alpha beta. You will get ethene as a product, that is B. When ethene that you treated with HBr, it undergo, right? It undergo free radical addition. You will get CH3, CH2 and Br, right? Then next one, Marconi-Coste rule, we can't apply here because it's a symmetric one. It's a compound C that on treated with the what dear all? Bromobenzene. Bromobenzene with the what? Sodium and dry ether. You know very well dear all, it's a haloalkane, it's a haloarine. When haloalkane mixed with the haloarine in presence of sodium and dry ether, it undergo Wurtz-Fittig reaction. The bromine is taken by sodium, the benzene connected to the alkyl chain. You will get ethyl benzene. So what is the answer dear all? Option 4 is the correct answer. Next one. The pimastrone is an example of, dear all, pimastrone is an example of which one? Solid sol. It's a process, it's a system, it's a colloid like gas in solid, right? Pimastrone example for the colloid system is compulsory to know, dear all. Next one. Last one question. Peroxodisulfuric acid. What is peroxodisulfuric acid? H2SO8. So what is sulfuric acid? H2SO4. And pyrosulfuric acid is which one? H2S2O7, right? And H2SO3, right? There are H2S2O8, peroxodisulfuric acid. What is the structure? Peroxo, option A structure I'm just drawing here all. S double bond O, OH, then OO, and S double bond O, OH. This is the structure of what? Peroxodisulfuric acid, right? Here, how many SOH bond, S double, whether you know the structure or not, that they're checking, right? How many SOH bonds are there on? SOH1, SOH2. So there are 2 SOH bond, all right? How many S double bond O bond? 1, 2, 3, 4. There are 4 S double bond O bond. And how many SOOS? See, SOOS. Yes, there is one SOOS bond. So what is the SOO connection? That is a peroxide connection. That's only in which acid, the oxoacid of sulfur, that is peroxodisulfuric acid. So dear all, we can able to say that A is matching with one third one. A matching with the third one. That's 2 options are there. That is 1 or 3. Let me go for the other one. Sulfuric acid is there. Pyrosulfuric acid. If you know peroxodisulfuric acid, pyrosulfuric acid is easy, right? Let me take the third one once again. You know, in third one, is same like this one. Instead of OO, there is only one oxygen, right? OH, O, double bond O, OH. This is what? Pyrosulfuric acid. Where you can able to see how many SOH bond? 1, 2. There are 2 SOH bond. And what you need? Another S double bond. 1, 2, 3, 4. 4 S double bond O bond. and there is only one SOS, right? There is one SOS bond. So what is the answer here? All together 2 SOH, 4 S double bond O, 1 SOS. That is C we can match with which one? First one. So A3C1. A3C1. That's only one option. Option number 1. So this is from the topic what? The P block element grade 12 from the sulfur, the oxo acids of which one? Sulfur, chlorine, that you may studied from the, this is from 16th group, right? So dear all, overall the chemistry paper when you analyzing, most of the questions are very simple and very direct question. Only few confusion from the statement 1 assertion reasoning question, except all the questions as a paper analysis. Overall chemistry, I feel it's a very easy one. Hope you did very well. And again practice the question for the upcoming 2020 for the next year, the NEET examination also, those who are preparing for that one. So keep hard work dear all. Read NCERT textbook line by line. Keep concentrate on the reactions, line by line reading, analyze the graph, etc. This is the only one solution to crack the NEET examination and all. So wish you all the very best and hope you clear all the questions which we discussed here. Thank you again. Bye.